Good morning, everyone.
Morning, Andrea. Good morning, everyone. And thank you for your participation in this GM International webinar dedicated to safety relay and their application. Welcome, Andrea. Ciao.
Hi, Massimo. Thank you for us. It's very early in the morning, but for many of you, maybe it's in the middle of the day. Let's say wait 1-2 minutes because I still see people connecting.
Yes, perfect.
Yeah. So maybe 1-2 minutes, please, for wait. Okay, Massimo, I think we can start because I don't see any other people coming.
Okay, well, good morning again, and thank you for your participation in this GM International webinar dedicated to safety relay and their application. Well, today topics intend to provide a general overview into the world of SIL certified safety relay, always readily used in the process automation application. A little explanation on how our meeting will take place today. Our webinar will be mainly divided into two parts. A first part dedicated to a short presentation where Andrea will introduce the main concept related to the safety relay and their application. The second part will be left free for your question on the topic, in which Andrea and I will try to give an answer. Please don't use the chat for your question, but use the question and answer function on the Zoom. Next slide, Andrea, thank you. Before starting with our presentation, let me introduce in short myself and my colleague. I'm Massimo Pagani, Product Manager and Technical Support at GM International. I've been employed at GM International for about 8 years, and my main role is to receive and process customer technical requests or assist them in their correct choice of products to be used in their application. Furthermore, I collaborate with our research and development department for the implementation of the new devices to be put on the market, and with the sales and marketing office to promote GM products worldwide. As already mentioned, I have a pleasure to having with me today Mr. Andreas Polar, our global manager account. Andrea has over 20 years of experience in the machine automation market. He has great expertise in international relations in the automation sector and has consolidated his experience in Europe. Now he takes care of customers and markets worldwide. So before Andrea starts with his presentation, I would like to introduce my company. GM International was born from the experience of Elcon Instruments, and for over 25 years designed, engineered, and produced a complete range of SIL certified intrinsic safe devices. Our products are used in automation packages such as DCS, ESD, fire and gas, marine, and so on, in several industrial sectors as oil and gas, petrochemical, pharmaceutical, food and beverage, and railways. The next slide, Andrea, show the complete range of our products. Here we can see intrinsically safe barriers, safety relay, which we present shortly, isolator, multiplexer, seal-free power supply, termination board dedicated to the most popular PLC DCS system, ARC multiplexer, etc. In addition, our company promotes advanced course of functional safety, conducted by an expert trainer such as Tino van de Capelle. You can find all the information about it on our website. The goal of our company is to provide and guarantee innovative and high-quality products. All our products are tested one by one and must comply with the strictest work specification. Our products are ethics and SIF-free systematic compatibility certified by third party. Furthermore, over 15% of GM employees are engaged in research and development of new technologies. Many of our resources are reinvested in the research and development department. And last but not least, all our products are covered by 5 years warranty. GEM International has always been perceptive to market demands. For this reason, its products are innovative in order to get maximum customer satisfaction. The strong point on which GEM International bases its activity is the complete pre- and post-sales assistance in order to lead its customer to find the best solution for their application and to assist them in the correct use of the product. In addition, all our products are entirely designed and produced in our headquarters in Italy and are tested in highly automated process. The following slides show how GM International is located around the world. We over 200 people who make up our staff distributed in all continents. We have product stocks distributed in our main branches in Dubai, India, Singapore, Houston, and from this year also in Moscow. The last slide lists some of our main collaborators and customers distributed among the system vendor, APC, O&M, and the end user. Well, now I leave in Andrea time for his presentation on today's topics. Please, Andrea.
Okay, thank you, Massimo, for the introducing. Thank you to you for waiting. So just to give you an idea about GMI and what product we produce. And the topic today is safety relays. So safety relays is, of course, is a very important part in application, the process applications. And here is an example of a loop where you have an entire loop from the sensor to the actuator. And of course, this any product that is participated to the loop must be must have a seal certification in order to keep a certain level the seal loop. And if you see here also the product solver or the sensor or either the barriers, the relays, whatever is the system must comply with the same. I want to start now with a short poll. If you want to answer to us, it takes just 1 minute. Let me.
Sorry, Andrea. Can you share to the full screen your presentation?
Is not full screen this one?
No.
Okay, a lunch poll. If you want to answer, we take just 1 minute to ask. Okay, thank you. Start now. So most of you use, just for your information, CL2 and CL3 safety relays. Some of you with the smart relays with the line and load monitoring. Okay, let's go further. So safety relay.
Sorry, but I see the presentation.
Not the correct way.
Yes, is again not in a full screen.
It's not in the full screen, so share. So sorry for this problem. I will start again the sharing. Wait, sorry for these troubles, but sometimes it can happen. I think you can understand us. Let me start again. Is that okay now?
Okay, you can go.
Okay, thank you. So safety relay is a product, of course, must be used in any critical applications. It must adhere to ESC 601508, which is the relevant, let's say, norm in the industry applications, okay, in the manufacturing application. For information, GMI has to comply to ESC 601508, while you as a user, as a system integrator, as a company that work in the area of critical application must adhere to the 6015. When you can use or when you have to use safety relays, typical cases are when the controller is not able to give all the power requirement for the load in terms of voltage or current. Or when you maybe need the multiplication of contacts. You have just one contact you want to multiply. Or maybe when the function must be inverted. So there are typical applications in this area. And but still certified relay not only used in oil and gas or petrochemical industries, but can be used also in other industries. And we have many applications: railways, car lift, power distribution, and any other, let's say, application where there is a risk that is must be, let's say, reduced by using SIL solutions. Okay, up. So this is the typical application, and on the field side we have a load, okay, and this load is connected to relays, and these relays also, of course, the contact is the load is powered through external power supply systems. Application we already said about market, but here about the real load can be solenoid valve, can be used in EST or Frankel systems. We have a lot of application for beacons, horn, lamps, sounders, and other signaling devices. It's used also in BMS, burn management systems, and also for application for AC or DC motors. The application for relay is always very simple because it's start, stop, on open or close. So it's very, very simple. But of course, the safety must be at the highest level. Of course, standard relay cannot be used in a SIF, as we said. If you have a loop which you want to reach a certain level of cell, also the relay that is introduced in that loop must be CL certified. Okay. So CL certified relays is a relay with a really known warranty ability to perform a given safety function. So there must be really an FMEGA calculation for that relay is available. And as we say, the safety function is aimed to reach a specific safe state on demand. So you want to open or you want to close something. Application maybe can be also a relief valve or activate a fire extinguishing system. Most of applications are non-energized, so you want to reach and de-energized situation. So the situation is a DTS, de-energized to safety, and this is ESD application, typical IPS BMS also. Also, you can have a fire and gas application, non-energized, de-energized. You want to energize for safety. Okay, and safety function, as we said, are divided in two main groups. So energized to safety or de-energized to safety. And in this case, you can have two different operating conditions. Okay, so you have your non-energized coil, you have your non-energized load. So the relay are normal open relay contacts. And you have the other type. So you have four different situations where you want to invert and you want to maintain the same function on your system. Let's go to the next one, but maybe can give you more idea about the application. So in this case, you have your coil, which is non-energized, and you want to reach a safe state. It means open the relay and open the load connected. So normal energized and normal energized coil as well. The opposite is when you have the coil, which is normal energized, and your load is normal de-energized. The safe state in this case is the opposite, so you open the contact and your load will be on. You can have also this application where you have your coil, which is normally energized, and your load is normal energized. The safe state means that I activate my relay and open my load. This is the opposite, let's see, for normal de-energized situation, it's completely the opposite. It's just to give you a few ideas about how the relay works. So in this case, we can say that let's make some example. So you have the load normalized and coil normal energized as well. So in this case, the cell level is you can obtain in this case with just one relay is a CL2. So with one relay, you obtain the CL2 level for your application. If you use another relays, in this case, you see that there are two relays in series for normal energized application. By having two relays in series, I can reach the CL3 level. While if I'm using application normal de-energized, okay, just one relay is enough for reaching CL1, while for normal energized was CL2, if you remember correct. So if you want to reach a CL2, I have to use another relay, which is connecting parallel. If you want to reach a CL3, I have to use a third relay, which is connecting parallel. That is the typical applications. So if you see the higher number of relays I use in my system, the higher level of seal I will reach. But we have talked about safety because the norm IEC is talking about only the safety, not the availability, but also availability is very important because it increases the, say, the possibility of running your systems without having spurious or unwanted trip. So in this case, I see that in norm Energized, if one relay is having a fault on my application, of course, my loop will be stopped, deactivated without real reason, safety reason. So I say that in this case, I have high safety, partial safety, because I reach a CO3 safety here, but low availability because one relay is forcing the system to stop. Also for normal de-energized CL3, if one relay is activating by errors, my load will be on. So in this case, I say that I have high safety but low availability. So there is you see that in this architecture, there are of course different behavior about safety and availability. And also, this is also very important, I guess, also for you, because if you're talking about normal energized load, I can have different architectures, and one relay, two relay, three relays, and more. And in this case, I can have one out of one out of two. So one out of one means one relay, one out of two relays in series, two out of two relays in parallel, and the situation voting where you have three relays working, okay? And looking at this one out of one, I see that here there is MTTF, means mean time to failure, safe failures, mean time to failure, dangerous failures. So the last column is the most critical and important part, of course. But also this is means about spurious trip, so the unwanted trip on my system. So in this case, for one out of one, I have an time for spurious trip that is 25 years, while for dangerous trip is 50 years. If I use two relays in series as the architecture to reach the CL3 that we have seen in previous slides, of course I see that increase a lot the dangerous failure time, because it is 50 times more. So it means 2,500 years. While I'll say I reduce a lot also my spurious trip. So by the one out of two architecture, I have, let's say, more safety, but less availability. Okay. If I use the 2 out of 2 configuration in this case, I see that for, of course, this is not a good architecture for normal energized. It would be great for normal de-energized, but it's just an example. I see that with 2 out of 2, I reduce a lot the dangerous failure time. So I can have more failures on my system, but have very high availability. And I'd say that with system voting, where you have 3 relays and 2 relays, of course, I have to say that the same things. I have to say that I have to close or have to open. In this case, I see that I increase a lot my time for dangerous failures, and also increase my time for spurious failures. This, just to give you an idea about what is what can be the architectures. In our, especially in our relays, we have we are using 2 out of 4 architecture that increase a lot. Of course, it's very safe, but also is increase a lot the availability. You can have also nice in our systems, for example, with architecture 2 out of 4, we will see later. And say we can tolerate 2 phase on the relays. Okay, I wanna, if you don't mind, have another poll, and maybe it's would be great if you can answer to this as well. So what feature for safety is most relevant for you? So take your time. Okay, I can stop. I don't see for the vote, so I see that the most relevant for you is CL3 and also high availability. Okay, thank you for voting. We can go to the next. I see people that are raising hands. Maybe we can. In the slide 26, I think this is asking, in the slide 26, what is the second contact in series with A? Contact 1 or 2 configuration. Let me go back. So, okay. So the question is, okay, here. It's what is the second contact in series with A? This is here. I think you mean this one. So it's not. Maybe it's
error.
It's an error mistake here, but here there are only 2 contacts. Okay, I think we will share also. You can see this presentation on our recording files on our YouTube channel. So later on. Okay, and we've talked about architecture 1 out of 1, 1 out of 2, 2 out of 2, and 2 out of 3. This is our architecture that we realize on our relays, that is the 2 out of 4. So you see that we have a load which is derived through architecture where we have 2 relays in parallels in series with the load, another 2 relays in parallel. So we have 4 relays working for the same functions. So let's see what is, this is improving safety, and this kind of architecture. So means that 1 relay is not sufficient for the dangerous failure. So if a 1 relay is stuck in here, in this case, I'm able, for normal energized application, I'm able to open the circuits because these 2 relays, the 2 bottom relays, are opening. And on the other, on the other side, if you look at the normal de-energized application, when I want to close my circuits, all the 4 relays are working, but 1 is not working correctly. But I see that the circuit is still closed. So I can have here, let's say, hardware fault tolerance 1. So 1 relay can fail without compromising the safety functions. But it's also this kind of architecture is also improving the availability, because availability means that I'm working on non-energized. I don't have any, let's say, critical situation. I don't want to stop my plant. And but one relay is failing, so it's opening accidentally, and still have my function working properly, because the circuit is closed.
Okay, sorry, Andrea.
Yeah.
We have a question from our attendee.
Yeah.
What should be the testing interval for each type of configuration? But we can say that this kind of information are included in the safety manual related to the relay. You can find all information about this on the safety manual.
Yeah, but it's also depending on the manufacturer.
Yeah.
So it's depending what kind of component. It's a very complicated answer. It can be maximum 1 year, 2 years, 3 years, 8 years, depending. If you want to have a CL3 or CL2,
Yeah,
it's very manufacturer depending. Say.
yes. Thank you, Andre.
Thank you too. And so we've seen the different kind of architectures, and also, of course, there are relays that are offering built-in diagnostic. And why is it very important? Because I'd say old systems especially do not have a diagnostic. So if you're using old system PLCs and so on, maybe don't have this kind of diagnostic. I have in mind some manufacturers that don't offer this kind of, especially DCS parts, not the PLC or the safety. And it's important because, of course, the digital output for the system are voltage and current limited. Or maybe the diagnostic inside some limits, so they don't detect let's say extreme load or current leakage. Smart relays or relay with diagnostic make the diagnostic available to the systems. And of course, extended DO compatibility, and they give you real-time alert for any load, either for normal energized or normal de-energized applications. I finished my part, which is the we give you some ideas why it's important to use safety relays. And now we have another part, if you don't mind, which is also, I think, very interesting, where we have we collect some information and questions about the safety relays. So let me share the next presentations. So if you are in the meantime, if you have any further questions to ask, please don't hesitate to raise your hands or write in Q&A questions.
Yes, I want to remind our attendees that they can ask their question through the Zoom question and answer function. The second part of our meeting, we show what are the typical questions which are most frequently asked to us on the relay topic.
Yeah. Massimo, it's your turn for this part.
Yes. The typical question that we can receive is, can the safety relay be installed in the hazardous area? Yes, it's possible to install a device such as a safety relay in the hazardous area, placing it in a special enclosure certified for the installation area, or as shown in the slide, in more cases, there are safety relay that have certification for installation in zone 2. In the slide, we can see the typical marking on for the relay that have the possibility to have the installation in zone 2.
Massimo, there is a question from.
Sorry.
In safety circuits, normally we use 24-volt DC for the relays. Is it permitted to use 110 VAC or 220 VAC relays for safety function?
Yes. No.
Why not? There are no, let's say, we are talking about safety, not hazardous areas mainly.
Yes.
In the safety means that you have to keep certain safety systems, and so there are no limitation for current or voltage loads. Important thing that you are using, you have to use SIL certified solutions. That is the most important thing. So you can also use any kind of voltage loads. Okay, we can go to the next one.
Yes.
Next question.
Okay, another typical question is regarding to the compatibility with the safety relay with the pulse testing function of the PLC DCS. Almost all PLC DCS systems have the possibility through a series of pulses to test the status of the line that connect them to the relay coil. Compatibility with these pulse trains is very important in a safety relay. First of all, to allow the correct test of the line, and moreover, to avoid that this pulse causes the chattering effect in the relay, or spurious activation or deactivation of the load, as well as damage of the relay itself. But I want to say that in the GM International portfolio, our safety relay of the new D500, 5000 series is all compatible with the pulse test from the PLC DCS.
Okay, thank you, Massimo.
Another question, typical, is there any solution offering multiple contacts output? Yes, the answer is yes. There are solutions that provide for multiple output contacts controlled by a single input. This means that this multiple output allow us to have multiple loads connected and driving simultaneously. An example is this shown in the picture, is the D5219S078 from GEM International portfolio. With this kind of relay, we have the possibility to drive more loads in the same time with the same relay. Typical application, we have the possibility to have 2 normal energized load SIL-free, or 4 normal energized load SIL-2, or again 2 normal de-energized SIL-free load.
Okay, thank you.
Okay.
Other question?
Yes.
It is required in any application to install an end or line resistor with the GM relay recommended by GM. If yes, how is the resistor value finalized? So the end or line resistors with GMI relays.
Yes, GM end-of-line resistor typically are used in the application that involve the smart relay, relay with diagnostic, and end-of-line resistance usually are used with a particular load with as a beacon, because this kind of load have an input impedance very unstable, especially in off-state. They show very high impedance, and for allow to the diagnostic circuit to work correct, we need to insert in parallel to the load end-of-line resistance. The value of the resistance typically depends of the power supply of the load, because it's different if we use or if we supply the load with 24 volts or 230 volts. But
this depends only from the load, because you say that.
Yes, depends from the load, from the power supply of the load.
Okay, but if you're talking about a valve, do we need to use end-of-line resistors or not? Sorry, valve.
But in this case, depend from the type, the input circuit of the valve, because there are a valve that have an input, a particular electronic circuit that allow to keep the consumer low. And in this case, often we need to insert end-of-line resistance to allow the diagnostic circuit of the relay to work correctly. In another case, all the series of valves that not have an internal electronic circuit, in this case is not necessary to insert the end-of-line resistance. Depends on the load. We can study case by case on basis of the load that we use.
Just one technical things. I see that people raising hands. Please use a Q&A and write your question. Is only the permitted way to say participate actively to the webinar. Okay, so next questions, Massimo, is Massimo?
Yes? Sorry.
Okay, Q&A. Let's go to Q&A.
Another typical question in regard to the typical two connection, unipolar or bipolar connection of the load. The safety relay can be connected in unipolar or bipolar configuration. Please, Andrea, show the next. Thank you. A bipolar connection allows us to completely isolate the load, and this is recommended, especially in the application where the load must be powered with high voltage, 230, for example. From an electrical point of view, this type of connection give us greater safety thanks to the complete isolation of the load. Instead, unipolar connection isolates the load only on one of the two power supply lines, but and allow us to bring a negative to Earth in case of need. Furthermore, this type of connection allows us a great benefit from the point of view of cable savings. This is the mainly characteristic that compare the two kind of connection.
Okay, thank you, Massimo. There is one live question from one attendee.
Okay.
Is if in the safety application, if all the relays used and also the power supplies are SIL3 compliant, does it mean that the safety function is SIL3 compliant? I understood from the example shown by you today that the wiring configuration also has influence on the SIL level of the SIF. Is understanding correct? Let's say that if you're using all SIL3 components and in the loop, and you are not sure that your loop will be SIL3. It is not because it depends on the calculation. I would say that at least maybe you reach a SIL2, or maybe you can reach a SIL3 by increasing the testing proof on certain critical parts. So only products, for sure, if you're using not SIL, you cannot reach a SIL. If one product, for example, is not SIL, your loop won't be SIL, for sure. But the other way around is not correct. If you're using all SIL3 component, you're not sure that your loop will be SIL3. Maybe you have to adjust, maybe you have to increase or test much more the valve, which is the most critical part of your loop. But only using SIL3 product is not sufficient to reach a SIL3 level for your loop. Okay.
Thank you, Andrea.
Answer. So let's go to the next question, Massimo. Here.
Yes. How choosing a relay, safety relay?
Yeah. What kind of parameter you have to know? Okay. For choosing a relay. Okay.
Yes. The choice of the correct safety relay must be made taking into consideration various factors, such as the compatibility with the PLC pulse test system. This is very important, as previously seen, because this allows us to avoid the spurious strip or damages of the content.
It's also important, Massimo,
Yeah.
I can say, it's also important because on some system you can exclude the pulse testing, you can stop, on some others not. The pulse testing is still alive. So if you're using safety relays, not only our, but in general, let's say, from other manufacturers, you have to check if this pulse testing must be excluded from the system. If not, your relay must be compatible. Otherwise, your load will flick continuously and you will damage in a short time. So that is a very important thing you have to know on your for choosing your relays.
Yes.
Okay, sorry for stopping.
Okay. We have such as PLC coil voltage, because we can have different voltage to drive the coil of the relay. For example, to 24 volt or 120 volt DC or 230 volt AC. Other very important feature is the load type and the safety function, normally energized ESD or normally de-energized fire and gas. I want to say that is very dangerous. Choose a wrong safety function and choose the incorrect relay for the safety function that you have to realize. This because if you choose a normally energized relay or normally de-energized safety function, this is a very dangerous for the application. This is a very important thing to choose a correct safety relay. Other feature is a line and load diagnostic. There are smart relays that offer to us the possibility of monitoring the status of the line and the load. This kind of relay have the possibility to monitor the open or short circuit, the status of health of the load, the supply, power supply of the load, and in some cases, the earth leakage and so on. Other important feature is the contact. We can choose between a relay with a single output contact or we can see in the previous presentation multiple output contact. And another important feature is naturally the current rating of the contacts, 5 amperes, for example, or 10 amperes.
Okay, thank you, Massimo. I don't see live questions, so we can go to the next one.
Okay. Can the fault for a monitor relay be mirrored directly to the PLC DO card? Yes, we can also say that there are relays that when they detect a fault in the field, can, through a variation of the dynamic impedance of its input, send a false signal to the most modern supervised PLC DCS system. This function allows us to reflect information related to the field fault directly to the supervised DO card of the PLC, both in off state through the pulse test system and in on state by reading the static current return of current. The DO card of a PLC system can detect the information related to the field fault. This system, through an upward impedance variation of the relay input circuit, allows the supervised DO to see the fault in the field. This system allows considerable saving in engineering cost, as it allows us not to use a dedicated card, digital input card for this purpose.
Okay, I wanna just inform you that we have another webinar dedicated to the application for safety relays, and there are much more information regarding the diagnostic relays, and the relays with diagnostic parts. And it is, if you look at our program for webinars on our website, you will see you can check the dates and reserve your seat for that next webinar.
Okay.
Thank you, Massimo.
Thank you.
And go to the next.
Another typical question that the customer placed to us is, can the fault for a monitor relay be interfaced via field bus? Well, there are particular safety relay models called smart relay, which can provide a complete diagnostic information through Modbus multi-drop RS485 protocol, if a Modbus master is available on the system side. Up to 127 modules can be arranged in a multi-drop network and monitor configured by a single master unit, as shown in the following picture. Each slave contains tables of parameters. Each of them is univocally identified through an address, and when requested, makes available its value for reading writing. What are the advantages of using Modbus communication? With a single Modbus RS485 interface, it's possible to connect and communicate with all the relay present on the same bus. Multi-drop connection is possible and can cover a distance up to 1,200 meters. Another advantage is the possibility of not using a dedicated EE system to monitor alarms. This allows us to have significant saving in terms of cost. Real-time information on the type of alarm and on the health of the load and the line. And it's possible to Modbus a complete remote programming of the relay. This is the main features for the Modbus communication of the relay. Thank you, Andrea. I leave you the next slide.
To me, yes, okay. The question we got was also a SIL3 relay can be used in the SIL2 applications. So, of course, this is a typical question. So we provided some useful information here. So for maybe for the one that are not really familiar with the SIL, so the SIL level can be 1, 2, 3, and 4. Okay, most dependable, the fourth. And so the highest is the 4, the lowest is, of course, the 1. And of course, the SIL3 relay can be used in SIL2 application, but not the other way around. Of course, if you want to reach a SIL3, leave your loop was the question from an attendee before also, you have to use at least a SIL3 product. But you are at the end, you are not sure that the SIL3 will be reached, but you have to use SIL3 product for using to reach a SIL3 on your loop. Of course, if you're using a higher SIL level than necessary, allow to reduce the frequency of T-proof test. So when you are using SIL products, of course, this is a SIL for some years, for few years, 2, 3, 4 years. After that degrades on time. You see here on the on this graphic here, you start from time 0, and you are on SIL3 level, and by the time you can you go to the SIL2 areas, and you reach a SIL1 also if you don't test it. Okay. So in any safety manual, any safety related products, there is also this let's say the procedure for testing. So it gives you all details how to test the unit in order to keep a certain SIL level on your unit. It means that after certain year you can test it, and you can start practically from 0, and you can start in this case from SIL3 level in order to keep a certain safety on your loop. But what is the things also very important? If you wanted to use a SIL2 applications, want to keep a SIL2 level for your loop, you can use also SIL3. The most important thing that the SIL3 product can be SIL2 for higher number of years. For example, a SIL3 for 1 year could become SIL2 for 10 years. That is also very important. So if you use a better product, of course, that increase your flexibility and then you reduce your testing proof. So testing proof means you have to stop and test your device on your loop. Okay, I don't see live question. No, okay.
Oh, no.
Go.
Yeah.
Relay design aspects, that is also important. So in order to reach a certain cell level, you can use, of course, system characteristic different. So you can have more relays in this case in order to reach a certain level. And this architecture you see on say in real mechanical or connection parts for the relays are also used also for components. So there are redundancy, there are some dedicated architecture for also the single components. And but there is also, maybe you are aware about the beta factor that is also very important. The beta factor means that same product from the same manufacturer, from the same batch, can fail probably at the same time. So if you're using the same product, in this case, we use the same relays for 4 relays, of course, this affects the safety and will reduce what is the cell level for the units. So it's better to use different product from different manufacturer from different batch. That is the one important rule. And of course, we are talking about the components, so very important to use better component with a better SIF, with better functionalities, and for instance, gold printed relay, silver relay, and so on. That is also are very important features for producing and designing relays. Of course, and if you are buying a unit, relays, or any product which is claimed by the manufacturer that is a sale, you have that manufacturer has to provide you an F-meta analysis and F-meta calculation that is describing clearly what are the dangerous failure, the safe failure, MTBF, and so on. That must be really stated on the manual for the manufacturer. Not only the seal certifications is enough, but also the FMEA is also very important. Maybe we have one question.
Yes. Our attendee has, I understood from your answer that it's possible to conduct a pulse test on a safety relay from the PLC without disturbing the SIF. Are such products available from GM International? What is needed to be specified during procurement to take care of these requirements? Andrea, do you want to answer?
I think there are 2 levels of it's not past test, testing proof, I think, is mentioning the attendee, the testing proof. So in our manual, we can have 2 different testing proof for the relays. That is 50% and 99% testing proof. It means that The 99 is revealing, of course, is very accurate testing proof that is, in this case, you have to, I'd say, to stop your plant and practically having, let's say, shut down your systems and testing completed the release. And so that is revealing the 99% of failures, and that is the most accurate testing. On the other way around, we have also the 50% of testing that is revealing only a part of the failures, not the failures. And in this case, is not is more live testing without completely stopping the system.
Okay, thank you.
Okay, I think I don't see any further questions. Hope not. That's okay. We can go to the next one. We are almost finished. Maybe it's taking a little bit more time. I think it's also important for you. Why gold-plated contacts are important? I think you are aware about gold-plated that are really important when you are in the switching current is lower than 100 milliamps. Because small currents can cause oxidation and consequently also spurious or nuisance strips. It means that your relays stacking is let's say, is glued completely and is not moving. That is, if you're using relays with the component side which is not gold plated, can, in case of a small current, you can incur in such problem. So gold-plated relays are very important because grant high reliability for small currents. Okay, let's go quickly, otherwise people will leave. Coil voltage and relay load currents. So here we already say that a relay coil can be 24, 48 different relay coils, and currents can be 3 amp, 5 amp, different types. That is a way how to choose also the relays when you use the application. And C3 relays with the C2 diagnostic, how is it possible? Is it possible because the relays is the diagnosis is not completely interfering with the safety function. Safety function is a specific line, and diagnosis is just checking the systems and not interfering with the main safety functions.
In this particular case, Andrea, we can say that two different safety functions coexist inside the smart relay. The first and also the main function consists in the input to output or coil to contact activation, deactivation. This is the typical function of a safety relay, which upon request is able to drive a load applied to it in a safe state. The second one is the diagnostic function. It provides to measure voltage, current, resistance, or leakage of the load, also through Modbus protocol, and it can activate, deactivate through fault drive contact. In this case, the first one is SIF3, and the second one is SIF2.
Okay, thank you, Massimo. Difference between, this is probably on the last one, between process and machine safety relays. This is another word, complete another word, because for process safety, the seal certification is necessary. Application is, I will say, for SOV, SOV, solenoid valves, horn lights, sounders, beacons, and there is no manual control. Of course, it's a closed system, close the valve, or open the relays activate. So there is no possibility for a manual control. While for machines, it's a completely another application, and that machine application required certification, which is a PL, protection level, and it's for safety gates, barriers, grids, standstill, whatever is in factory. Okay. And there is a manual control because there is an knowledge. You see that there is a standard mushroom, red mushroom you see on the factories that is controlled by, is the control for a release. So there is a manual control, complete another application. We are talking about process and not safety. I think we probably finished. So you will see, if you go on the website, GMI website, you can check for live webinars. The new, let's say, all details are there. You can reserve your seat. You can also see this webinar because it has been recorded on our YouTube channel. You will see all this webinar, also the other. So thank you for participation. There is a last question.
Yes, yes, Andrea. Is additional fault out SIF compliant?
Yeah, additional fault out.
But the typical, the main function is a SIF, but the fault output, even present on the relay, are not SIF compliant, usually. Typical.
Okay. Okay, there is, in case another question, in case of a load, solenoid call, which is a certain operating current, X amps, and a certain switching current, Y amps, how do we choose the safety relay? Is it for X amps or for Y amps? So there is an operating current and switching current. What is, Massimo, do you have an answer for this?
But is important the operating current is to choose the correct current rating, and for the switching current usually we that consider the in rush peak that we explain in our instruction manual.
Okay. I think we almost finished. We don't have any
question.
No further question. Okay. Thank you for participating.
Thank you, Andrea. Thank you, our attendee.
Everybody, and I remember you there is another webinar dedicated to the live application, to the real application for safety relays, maybe for also for the smart relays. And you would say, if you get interested in that, don't lose it. Please reserve your seat over there. Thank you very much, and let's see next.
Thank you.
Webinar. Thank you. Bye bye.
Bye bye.